Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be looking at the fractional distillation of crude oil. Now, crude oil is a mixture of different hydrocarbons. It's a thick black liquid which is found underground and was formed millions of years ago when organic matter like plants and animals under high pressure became oil. So crude oil is a mixture of hydrocarbons of different chain lengths. Now, because it's a mixture, we cannot use it as such on its own. What is important is that we take this black mixture and distill it to bring about the different constituents that are available. So if you look at it, what happens is we take the crude oil, and the crude oil is heated in a furnace to about 400 degrees Celsius. And we see that the crude oil at 400 degrees Celsius is passed through the tower that we have here. Now, this tower is called a fractional distillation tower. And we see that basically what happens in this fractional distillation tower, it's a cooling tower where at the bottom the temperature is 400 degrees Celsius, and as we go higher, the temperature becomes less, 370, 300, 200, 150, 20 degrees Celsius. So as we go higher up in the tower, the temperature decreases. So in this cooling tower, we see that at different temperatures, different hydrocarbons will condense. And the longer the carbon chain, the higher the boiling point. So if you look at this example here, we see at the bottom we've got lubricating oil and we've got paraffin wax. Now, if we have a lubricating oil, paraffin wax, and asphalt, we see that they have very long carbon chains with 20 carbons or more. And because they have a high boiling point, they form a thick um, residue at the bottom, and they can again be distilled in another tower. But basically, we see that these things are formed at the bottom, and asphalt, for example, is used in the manufacture of roads, and paraffin wax. We know what is paraffin wax and lubricating oil, and we know that lubricating oil is also used in lubrication of engines. Then going higher up, we see that we get at maybe 370 degrees Celsius, we get other compounds that are formed, and here it is described as fuel oil. And fuel oil is also called bunker oil, which is used to power engines in ships and aircrafts. And it's basically the crude oil that is also transferred by the tankers that we know about that create huge oil spills when there is a tragedy, catastrophe that happens. Then at higher temperatures, we see that we got diesel oil, which forms carbon chains around 16 to 20. And these carbon chains are longer than petrol. We can see that petrol is higher up and diesel is lower down. So diesel has a higher boiling point of 300 degrees Celsius because it has longer carbon chains. And also, we looking further, we see that when we go higher up, we see that kerosene is formed, and kerosene is used to heat house or heat kerosene lamps, which are used in houses, and they have a carbon chain between 12 and 15 carbons in the chain. And higher up, we see that we have petrol, and the petrol that we use is a mixture of hydrocarbons that have carbon chains between 5 and 8 carbons in the chain, and that is the petrol that we use. So the lower oils, for example, lubricating oil, fuel oil, diesel oil, have higher boiling points, and they burn much more slowly than the higher substances. Therefore, diesel burns much slower than petrol. And going higher up on the higher part of the cooling tower where it's so-called the coolest, we see that the temperatures of 20 degrees Celsius, we see that we get the LP gas that is formed, the LP gas, liquid petroleum gas, that is used in the K-deck canisters that we use. It is used to make gas braais, or it is used in lighter fluid, in lighters, etc. And even at high, in fact, when there are certain hydrocarbons like methane that boil at minus degrees Celsius. And if we have certain cooling towers that have tubes that take those gases away and they refine them separately. So here is an oversimplified diagram which shows the fractional distillation of crude oil. Crude oil cannot be used on its own because it's a mixture of different hydrocarbons that have various varying chain lengths. So what we have to do is have a distillation tower and a cooling tower basically that has different temperatures. And as we go higher up in this fractional distillation tower, the temperature gets cooler, and at different temperatures different hydrocarbons will condense and they are tapped off and used uh, for the various purposes. So these are just some of the substances that are used: butane and propane, petrol, kerosene, diesel, fuel oil, lubricating oil, paraffin wax, and Epsol. And we see that they have so many different types of uses. So we see that crude oil is a very, very important um, chemical that when we extract the different hydrocarbons from it, we can use it for so many various purposes. That's why we see that oil is a very important commodity in the world today. Thank you very much for watching.